On page 63, we're going to understand 4.3, which is talking about points of intersections. And we know that if graphs are plotted in the same set of axes, and the two graphs are different, you will realize that fx will give the same values as gx. Those two graphs are equal at the point of intersection. And we are going to do this using example 5. Example 5 on page 63, and we're going to talk about, on the same diagram, sketch the curve of y is equals to x minus 3 and y is equals to x squared 1 minus x. It is clear that this is a quadratic graph and this is a cubic graph, due to the fact that this one, the highest power is 2 because of x squared, and the highest power here is 3x cubed. And let's just talk of this one being graph 1 and this one being graph 2. And let's start with graph 1. If we concentrate on x minus 3 being equals to 0, in an attempt to look for the critical values, you realize that x at some point, x is equals to 0 or x is equals to a 3. And those are the critical values. Again, if you happen to open this bracket, you'll realize that x squared times x times x is x squared, and the value of a is 1, meaning that greater, of course in this case a is greater than 0 because it's going to be x squared, so we expect a U-shaped graph. If you want to plot that or to sketch that, we will have something that looks like this. 0 is one point of where the graph passes the x-axis, and 3 is another point. So U-shape, you're going to have something that, it's a sketch, remember, it's not supposed to be very accurate, but of course you must name it. Y is equals to x minus 3. Fine. What about the other one? The second graph, which is now graph 2, if we take x, that being x squared, 1 minus x, then we are going to easily see that the critical values x is equals to 0, x is equals to 0 repeated, and x is equals to 1. So you can see this cubic graph passes the origin, it touches and leaves, so that's why 0 is repeated, and x is equals to 1, it passes through x is equals to 1. But the nature of this one, and I would want us to just do it over here, as x approaches negative infinity, what is y, or how does y behave? This is the only way we can undertake to realize the shape of the cubic graph as understood in previous videos. And if we talk about x being negative infinity, and the least value of x is 0, so we can easily take x to be equals to negative 1. And let's see how y behave when x is negative 1. So x becomes negative 1, and 1 minus 1 becomes 2. So if this is true, then you can see y is 2. So how does y behave? Then y approaches positive infinity. As x approaches positive infinity, and the highest value of y as far as that function is concerned is 1, let's take 2. This bracket will give us 2 multiplied by 2 multiplied by 1 minus 2, which is minus 1. So this is negative 4. So you can easily see y approaches negative infinity. Having said that, then we need to go back to the graph. As x approaches negative infinity, y approaches positive infinity. So this graph is coming from up, coming down. As x approaches positive infinity, y approaches negative infinity. And you can see our graph may look like that. And you name it, y is equals to x squared 1 minus x. At that point, you can clearly see that there could be 3 points of intersection. That is one. This is one, which is rather very obvious. And this is another one. We need to know the x coordinates of this point A. Let's call it point A. Let's call this point B and call this point C. When we are considering point B, we must be advised that at the point of intersection, now we are trying to answer part B of the question. At the point of intersection, at the point of intersection, x minus 3 is equals to x squared 1 minus x, which gives us x squared minus 3x is equals to x squared minus x cubed. And at that point, you know that after we collect the like terms, you realize that you're going to have x cubed being equals to 3x, because the x squared will cancel with the x squared. And dividing both sides by x, you find that x squared is equals to a 3. So at that point, it is important to know that x, getting the square root of both sides, is equals to plus or minus root 3. Those are the possible values of x. But remember, x can also be 0. So if we line them up here, we are going to see that x can be equals to negative root 3. It can be equals to 0. It can be equals to positive root 3, as you can see highlighted. And sure enough, this point represents the negative value of x. You can see where it is. It's on the negative side. This point is the origin, so it represents when x is 0, and this point represents the positive part of the intersection. Substituting this, now we should know that the other values, or the values of y, we should be realized when we substitute these values in one of the original equations. Now we say substituting these values in one of the original equation. Let's say we have y is equals to x minus 3. We should get the values of the corresponding values of y when we substitute. So we are simply saying when x is equals to negative root 3, y, what does y becomes? Y becomes negative root 3. We are substituting now, open bracket, this is negative root 3 minus 3. Opening this bracket, we have negative root 3 times negative root 3, positive root 3, positive 3. Negative root 3 times positive 3 becomes positive 3 root 3. So clearly, one of the coordinates, one of the point, which is point A has clearly has coordinates minus root 3 and the value of y is 3 plus 3 root 3. Those are the coordinates of point A. Point B, of course, when x is equals to 0, y becomes 0, 0 minus 3, which is easily 0. So point B, as you can see, is having coordinates 0, 0. At point B, you can see it's actually, you can already see point B is the origin, and therefore we are convinced that it has coordinates 0, 0. So when x is equals to root 3, y becomes root 3, open bracket, root 3 minus 3, which gives us 3 minus 3 root 3 as the corresponding value of y. So point C has coordinates root 3, and the value of y is 3 minus 3 root 3. So those are the three coordinates. Those are the points whereby the two graphs intersect. You can see point A, point B, point C with the coordinates as highlighted here. And therefore, yes, we have been able to plot the two graphs in the same set of axes, and you have been able to acquire the coordinates of the points of intersections. All right.